So it says this is kind of dumb because you don't even know how to regularly factor without a GCF. But just so you know what a GCF is, greatest common factor. If I had 2x plus 2, do you get they have something in common? Do you get that if I put a 2 times 1 here, it won't change my answer at all, right? 2 times 1, same thing as 2, isn't it? And now you can really clearly see that the 2 is in common. That's called a common factor. And so if I factor it out, this is the simplest kind of factoring. They both had a 2 in them. So you take the 2 out and you see what's left. And now this is really important. I'm really dividing them both by 2 then, so that I can put the 2 out in front. And that shows me what I have left. X and a 1. X plus 1. Now if I multiplied this out, 2x plus 2, and that's what I had in the first place. That's called a GCF. So there's no practice problems on that, but I know that's important, so I'm going to do it one more time. 12 plus 6n. Now it's not quite as clear. Do they have a greatest common factor? Buried inside the 12. Kennedy, put that cell phone in your backpack, please. If you keep doing that, I'm going to have to move you up to the front row where I can keep a closer eye on you. This has a 6 in it. And Gianna, if the 6 came out, it's like they're divided by 6. What's left? 2 plus n. And if you want to check if you're right, now this is one thing that's cool about this unit, is if you want to check if you're right, all you got to do is multiply it out. See if you're right. 6 times 2, 12. 6 times n, 6n. It was 12 plus 6n. You can check. I know I'm right. All right. So can you multiply this out? Well, we had that in last chapter. I'm finally confident that you'll know how to do it. First, outside, inside, and last. Go ahead and do it and get all 4 parts. Parts go together. You get a final answer. All right, EJ, what did you get? That's all right. You got x squared, right?
Yeah.
Keep going.
I got negative 7x.
All right, and that was the negative 9x and the positive 2x, and that was absolutely right. And that made 7x. And then all you got to do is last. 9 times 2, 18, but I did it wrong. Dang it. What did I do wrong? Negative 18. All it takes is an oops on a negative. There. Now, the point of today is to take it from this form, which is called standard form, back to this form, which is called factored form. So, of course, we know the answer already because they gave it to us. But if we hadn't already known, we would go, okay, x and x makes the x squared, and 9 times 2 makes 18. But I don't think you should do it that way. I think you should not do the numbers next. I think you should do the signs next. Because there is a negative, one of these two needs to be negative. I'm going to make the first one negative and the second one positive. So there's 3 stages. Stage 1, you get the x's there. Stage 2, you get the signs there. Can you switch them? Sure, it doesn't matter which one's negative, but they couldn't both be negative, or this wouldn't have come out negative. If there was 2 negatives, that would have come out positive. So. And then the third step is to figure out it's got to be a 9 and a 2. And I'm going to, on purpose, put them in the wrong spots just to show you, you don't know until you check it. You're going to check every single answer this time because it's part of factoring. And you go, first, x squared. Outside is plus 9x. Inside is minus 2x. And oh, crap. Oh, wait, I did do it right. My bad. I thought I did it wrong. What's going on? I'm a little confused. I thought it was supposed to be Oh, this was actually negative 7x here. If any of you didn't correct me on that and had negative 7x, you need to help me out if you see there's a mistake like that. There was a negative there. You know why? Because this was negative 9 and positive 2, so it was negative 7x. The kid who I called on had it wrong, and I didn't even notice. All right, so back to this. Now that I'm factoring this thing out, I'm realizing mine comes out to plus 7x minus 18. And that isn't exactly what I want because this sign was different than I expected. See, I want it to be negative 7x and it came out to positive 7x. So whenever you get the opposite of what you want, you change the signs to be the opposite of what they are. I'm going to say that one more time because it's so important. If you're ever getting the opposite of what you wanted, then change the signs, not the numbers, the signs. You'll see why later. Now, some of you are like, you could have changed the numbers, it worked fine. You'll see later when we're in more complicated questions that it'll always work if you get the opposite answer than you wanted to change the signs, not the numbers. There's a reason why I'm saying that. All right, let's go to another where we can do some more factoring. In 15 and 25, is there something in common there? 5. 5 is the GCF. In 12 and 4, is there something in common? 4. Because this is 4 times 3, and this is 4 times 1. Now they both clearly have a 4 in them. And how about this, though? X is the thing in common. There's no number like 3 or 7 that goes into both things, so not numbers, but there's an X in both of them. X is the GCF. All right, moving on. This is simple factoring. You just look for the GCF, greatest common factor. All right, look at this one. Put a parenthesis. Figure out what the GCF is and put it here. And then try to figure out what was in there. Carl, is there anything in common between those two?
2.
Yes, but there's something else besides the 2. 2x. So everybody put a 2x in front and see if you can figure out what to put in the parentheses. 2x is the GCF. Ashley, can you put your blue tag up? Lily, if 2x goes into both of them, you can do it like this. Divide this by 2x, divide by 2x, and then you'll know what to put here and here. Can you do it? This 2 cancels. Oh, okay. This one's 2. I get it. Cool. Yes, perfect. Not many people probably had that right. I know some of you did. Okay. That was a tough one. How do I know it's right, though? Like, how could I be sure I'm right? You just would have to multiply it out. In your head, quick, just distribute this out and see, doesn't that actually give you the answer that you wanted? 2x to the third, 4x, see? Now I know I'm right. That's how these kind of work. You try something and you go, did that work? Multiply it out and check. Yes?
Why would it be 2 squared and not, well, I mean, not 2 squared, x squared and not like 3 cubed?
Okay, let's multiply this out and see what happens. 2x, if I had just left this as a regular x, then the answer would have been 2x squared. But I wanted to the third, so I needed a 2 here so that it would be 2x to the third. All right, let's go to this one. Amelia, what do you see that's in common on both of them? Yep, that's one of the things we're going to factor out. Ian, can you tell us, it's not just x, can you tell us the rest of the thing that gets factored out? I know you were like, I thought it was x.
I don't know.
X squared. Because they both have an x squared in them, see? You might be like, well, one of these is to the fourth. They both have an x squared in them. So here's what you do to figure out what goes in the parentheses. You divide them both by 3x squared. Max, what do you think goes in the parentheses? This is the toughest one we've had.
It would be x squared plus 3x.
Oh, so close. And here's how you'd have known. When you go multiply this out, the first part would have been perfect, and the second part would have been 9x to the third. One too many x.
I have a question.
Yeah.
Is there a rule in which we're looking at x?
You mean like x3 versus 3x? Or
No,
what
like,
x?
What would be my greatest common factor?
Is there a rule to know what the greatest common factor is? Or what?
Yeah, like what does it have to qualify as? Like what does it have to have for properties?
Okay, the best way I can explain it is not a rule where you just like follow this rule and it will be right. It's more like you got to really look at each part and see what are all the parts to this. And you break it up into chunks. Like this is x squared and another x squared plus that 9 is really a 3 times a 3, and then there's an x squared. When you break it up into all of its parts, I think you're going to find it's pretty easy. Look at that above the blue line there. Do you get it's now pretty obvious they both have a 3, and they both have an x squared. There wasn't another 3, so as far as I know, there isn't a rule I can tell you that tells you the answer. It's more like just looking close. All right, so that's why 3x squared was the GCF on this one. All right, and how do I know it's right at the end? Because if you multiply it out, 3x squared times the x squared makes 3x to the fourth, and that was in the original problem here. And I multiply it out, and I get 3x squared times the 3 makes 9x squared, and so I know I'm right. Okay. Next one, and last one on this page. Everybody, I'm not going to call on somebody this time. I'm going to let the dice call on somebody this time. Everybody think of what comes out, put it in the front. That's called the GCF. I'm going to get the dice of destiny. Now, before I call on anybody, the way I just explained it a second ago is my favorite way of doing this. You break it up in little chunks. 2 can't really be factored. I mean, 1 times 2 is the same as 2. But x to the 5th and x to the 3rd and x squared, they can be factored, but I don't want to put x. I want to put an x squared, because see how they all have an x squared in them? Buried inside them, they all have an x squared. So I'm going to say that this is 2x squared, and there's an x to the 3rd left. I know this might be hard for some of you to do, but 2 times 3 is 6, and then now I can see obviously there's a 2 in it, and then it's got an x squared with an extra x in it. And last but not least, let's change to red again. I got a 2 times 2 is 4x squared. Now, I hope I made it obvious enough that they all have a 2. They all have an x squared. That was the harder part. And whatever's left, there's nothing left that I can say they all have 1. You know what I mean? Like the x to the third, they don't all have an x to the third. They don't all have an x because this one doesn't have an x, and they don't all have a 2. So the parts that are highlighted, that's the GCF. How many of you already knew it was 2x squared out in front? Okay, good. So then what do you put in there? My best tip for that is divide everything by 2x squared. And if I divide all of these, I already kind of cleaned them up there. I'm going to divide by 2x squared here and here and here. And then this cancels and this cancels. This cancels. The 2's cancel. Up. That cancels that, and that cancels that. And that leaves me with this x to the third. X to the third. And up here was 3x. And at the end, there was only a 2 left. That was intense. Was anybody able to pull that off before I said it? All right. Good sign. Okay. Now, this is the hardest. Actually, no, we do one kind that's a little harder, but this is generally the hardest kind. You get 2 parentheses, and I did already teach you this on the other day, where we were starting that other unit, and I thought we would just make you factor them, but then they were just giving them to you already factored. Turns out you didn't even know it yet, but now you do. And I start with the x's, and then I do with the signs. Do you get there's only plus signs? So I only use plus signs. If they're all plus, you just use pluses. If one of them is negative, you have to have a negative in your answer. If one of them is negative, you have to have a negative in your answer. You might even have 2 negatives, but that part's a little harder to tell. But you have to have at least 1 negative if there is a negative. Okay, so then 12. Dang, that's a complicated one because there's 2 times 6, 3 times 4, and 1 times 12. There's 3 things you could put. My advice, I know they taught you this when you were in algebra, but that was like 2 years ago. They told you that if it multiplied to this and added to that, that was a good way to do this. It's okay for now, but there's a better way. And it's really easy. Find something that multiplies to this and try it. What is something that multiplies to 12? Well, 1 times 12. And then in your head, quick, you'll get good at these. Does those 2 make 8x when I do the outside inside? No, so it can't be 12. You try it quick, you fail fast, and you move on. That's actually one of the best things about Silicon Valley, this place in the United States, in California, where they have all these new startup companies. And one of their culture things is try it. Trevor, that goes in the backpack now. Not the pocket. Thank you. And try it and see if it worked. And if it doesn't work, if it fails, let it fail fast so you can realize that's not going to work. Okay. So I'm going to try 6 and 2, and I'm going to see if it works. Outside, inside. Ooh, that one actually worked because it makes 8x. 2x and 6x makes 8x. So try it, fail fast. If you're like, oh, didn't work, then you know you try something else. And then if that doesn't work, try something else. They do that a lot in Silicon Valley. You know that Google has tried like 6 different things, and then they've thrown all of them out. They try it. Like there was something called Google Glass. They were these like glasses, like eyeglasses, that would show the Google search results on the screen of the glasses. It's a cool idea, but that failed. They tried it. It wasn't popular. People were feeling like it was an invasion of their privacy to have people walking around with these glasses that were like searching faces. And it's a kind of a cool idea, and it might happen someday. But they tried it. People didn't like it. They were getting kicked out of bars because they were wearing these glasses, which were like recognizing people's faces on the glasses. Again, kind of a cool thing, but it annoyed too many people. They were like getting banned, and so they were like, nah, we're just going to skip that. They tried it. They failed. Threw it out. There's been a ton of things Google has tried and failed and then thrown away. And a lot of companies do the same thing. I know Apple tried a car. Did you know Apple tried to make an electric car? They hired a whole bunch of engineers, to try to make an Apple electric car. They know because all these engineers were getting hired away from other companies to make electric cars for Apple. And then Apple went, nah, we tried, it's too dang complicated. They quit. So there was going to be an Apple car, and then they were like, nope, it's too hard. So they try it, fail, and then realize, okay, we got to switch to this. That's what I want you to do, is fail fast. So if you had tried 4 and 3, you would have realized that didn't work because you check it quick. 3 and 4 makes 7, not 8. So you have to check and see what worked. So the final answer on this one was the 6 and the 2, because 6 times 2 makes 12. And we don't leave when those chairs move. We leave fairly soon after that. So we're going to do this one more. Alrighty. This needs 2 parentheses. There's a 3-step process. Number 1, you put an X and an X. The next step? What's the next step? Signs. Does this need a plus and a plus? No. It's got a negative. So I have to have at least 1 negative. How do you know if there's 2 negatives? If there was a negative times a negative, it wouldn't equal a negative. So it can't be 2 negatives. You can use logic and you know it has to be 1 negative. And then last but not least, fail fast. What's a way to make 20? 5 and 4. But if you put in a 5 and a 4, it won't make an 8. So take out the 5 and the 4 and you put in something else. What's something else? 2 and 10. Let's check it. Did I get it? That's 10x. That's negative 2x. Do those two together make 8x? Yup. We failed until we found it. There it is. All right, we will resume the lesson after. All right, so we're starting on this page now, and I'm hoping you've got the 3-step process, X and X. Second step, signs. Does there need to be at least 1 negative? Yup. Does there need to maybe be 2 negatives? You can tell by how I'm asking it that maybe the answer is yes. Do you get... I'm going to show you. Do you get that if I didn't use 2 negatives, then these lasts, whatever 2 numbers they were, they have to make a positive. How in the heck can 1 negative make that positive 3 at the end? They can't. So therefore, that's the only time when you'll ever have 2 negatives. If they're both negative, it's because... there. If they're both negatives, it's because there's a negative here and a positive there. Now, it's going to happen rare enough that I think it's okay to just go with my generalization, which is, if there's a negative, then there has to be at least 1 negative. And then you're going to have to play with it until it worked. Because like at that moment, if you'd have screwed that up and you'd left this a positive, it wouldn't have been that big of a deal until you multiplied it out. And the first time you tried multiplying it out, you would have realized, I can't get a positive number here because I only had 1 negative. So, moral of the story, this one needs 2 negatives. Does that make sense to you at this point? Okay. Now it's 3 times 1. It has to be. The only way I can get a 3 is by going 3 times 1. And now I can just check it. And pro tip, you don't have to check all 4 parts. Just check this part and this part. Outside and inside of the whole FOIL thing. The outside ones and the inside ones are going to tell you the final, like they're going to catch it. If you've made a mistake, that's 98% of the time it's because these 2 will tell you you made a mistake. And if I put them together, does -3 and -1 make -4? Yes, it does. I checked it, so I'm probably right. If you really want to be paranoid, it's twice as much work. But you can check the firsts and the lasts. But I'm telling you, usually it's the outside, inside. You don't have to really check these top 2. Unless it's a test and you're being extra careful. Okay? And there, it's factored. And I'm done. That's the whole point, is factored. So I've got my factored form, which tells me the x-intercepts. You don't have to say this on the homework, but x equals 1 is the x-intercept and x equals 3 is the x-intercept. But wait, it says -3. It's what makes this equal 0. If you put a 3 in, a regular 3, it'll make it equal 0. They're called the zeros. All right, over here, I need 2 parentheses, 3-step process. Step 1, put in x's. Step 2, live. Can you tell if this needs 1 negative or 2 negatives? 2 negatives. How did you know? Well, probably because in your head you went negative times a negative will make it positive. Okay, cool. So next, the last step, which is 2 numbers that multiply to 3. Well, there's not many. It's got to be 3 and 1. And then I check if I see if I did it right. Outside, inside. Negative 1x, negative 3x, grand total negative 4x. Yay, I'm done. On this page, everybody get to this page. This is the kind. Oh my gosh, they're the exact same problems. That's freaking me out.
It's one side is factor and one side is solve.
Okay, thank you.
For the question above as well.
Yeah, my bad. Okay, so I just assumed they would be different questions. All right, so I took the 3x out. Can you finish it? If you're not sure how, I want to remind you, because this is a really important part, you would divide this and this by 3x. Divide it by 3x. And this part is just x, and this part is just a 3. And if you were like, but I thought it was 3x, well, double check it by multiplying this out, 3x squared, and this out, negative 9x. Ooh, that's what I wanted. All right, and the difference between factoring it and solving it is those where we just get the answers. X equals 0. X equals 3. I just put them on the wrong spot last time. They're the right answers, but I didn't put them on that. They didn't understand how the questions were set up, so. All right, now, this one is really important. A lot of people will correctly say that 2x can be factored out, but it's more important to factor out the negative than anything else. I know, but this doesn't have, they don't both have a negative. Trust me, when you factor, you want to factor out any leading negative number. I know from experience that when you go to pre-calc, it's one of the most common mistakes. People forget that to factor out that negative when they can. That way the answer inside the parentheses isn't negative. Because starting with a negative right here makes it all look weird and makes kids make a lot of mistakes on like finding the zeros, and so we don't want a negative there. So we put the negative in front. And now, let me think. What could go here? Let me check a 1. Nope, that's just negative 2x. And I need it to be negative 2x squared. So it can't just be a 1. What does it need to be? X. If you didn't know, you should have divided this by negative 2x. And divided this by negative 2x. That'll tell you what goes in there. Now see how I gave myself directions that tell me, oh, this has to be negative, because 12 divided by negative 2 is negative 6. If I hadn't written that right there, I might have very easily forgot that this is negative. But I would have caught it because I always check them at the end. I honestly don't even know if I'm right yet until I check it. So now I'm going to go this times this. That makes negative 2x squared. This times this, positive 12x. And since this right here is the same exact thing as this right here, the original problem, then I did it right. Okay, but what about solving it, Mr. Server? Okay, this part has to equal 0. if I just put in x equals 0, this part will equal 0. This part needs to equal 0. If I just put in x equals 6, then that part will be 0. There's my two answers. They're called the zeros. They're also called the x-intercepts. They're also called the roots. They're also called the solutions. They have 4 names, so they must be important. It's just these factors right here being set equal to 0. What makes that part 0? 0 does. What makes this part 0? 6 does. We're skipping that, and we're going to this last page because I want to get you into the homework. Liv, do you see anything that's common in all of those? 2. EJ, when I take out a 2, which I can do by dividing by 2 here, here, and here, what do I have left to put on the inside?
X to the second plus 8x minus 20.
Perfect. Now, a really common mistake to go, yay, I factored it, I'm done. But you can factor it again. Three-step process. X's, signs, negative and a positive, because I want it to come out negative. So a negative times a positive will make a negative. And then I got to think. And remember my advice, fail fast. That's what they say in nowadays fast-moving companies is you try it, and if it fails, awesome, you get to fix it quick, and then try again. And then if it fails, awesome, try it again and fix it until you get it right. So 5 and 4 makes 20. Fail fast. Outside, inside, that did not make 8. Not 5 and 4 then. What else makes 20? 2 and 10. So I put a 2 here and a 10 here, and I got to check it quick. Outside is 10x. Inside's negative 2x. It feels right. I just got to think it through. Does 10x and negative 2x make positive 8? Yup, it does. I checked the outside and inside, and I know I'm right now. Okay. Last melon. Do you remember me saying that it's really important to factor out a negative when there's 1 in front like that? And if there's nothing else in common, just take a negative 1 out. This is a pre-calc level skill. Like, we use this in pre-calc a lot, and kids like you often don't know that. They don't know you're supposed to factor that out. All it does is makes everything the opposite of what it used to be. Because it's like, remember me saying this? It's like we dividing everything by negative 1. It's like I'm dividing this by negative 1, and this by negative 1, and this by negative 1. So then I've got negative 6x, and negative divided by negative is positive 8. Everything is the opposite of what it was. And then you factor it again. I'm going to call on a random kid to answer this one. Be ready. Everybody must have an X and an X, right? And I'm hoping everybody knew there was a negative in it, so at least one negative. And is this the kind where there's 2 negatives? Look. I need a positive answer at the end. Yes, this is the kind with 2 negatives. So if the last number is positive, but the middle number is negative, I know it's hard to remember this. You just kind of have to think it through and go, would 1 negative be enough? No, it wouldn't. I need 2 negatives. Okay, and then the last part should be the easy part, and the dice called on row 5, third person. That is Kennedy. What do you get here and here? Just fail fast. Find me something that multiplies to 8. Okay, 4 and 2. And now I just have to check it. Outside, inside. Kennedy, what's the outside ones make? Good. What's the inside make? Do they together make a total of negative 6x? So therefore we got it right. And so the answers are x equals and x equals. For this one, I'd want 4. For this one, I'd want 2. So those are the x-intercepts right there. Okay, this was a super important day. Factoring is huge. In this class, like for this unit, that's basically it between now and break time. We're just going to get better and better and better at factoring. You cannot afford to be like, oh, I just didn't kind of get that thing. This is so important. Do you remember when, like, would you agree that when you learned how to add, it was so important because you do it all the time still? You still add. In your math class, you add like almost every day. Well, this factoring, I teach the classes above this. I'm telling you, next year, year after that, constant factoring. Like all over the place, all the time. So if you don't get this, it would be a little bit like your little brother coming up to you and saying, I really don't get adding. And you'd be like, oh, crap. You got to fix that. Like, because if you don't get adding and you still don't get adding like the rest of your life, you're going to fail all your math classes. Like, we need to fix that. Same thing with factoring. You might not get it right this second. If you're one of those kids that doesn't get it, please keep working at it. Keep asking me for help. Work at this one. This is so critical. I only get to pick one most important thing off of my basics sheet, and this is it. Factoring. It's the most important thing. Gotta learn how to do this. Okay. So, this was just, there we're done with that one. And now we have worksheet. We're not going to do that problem. We're just going to go to the factoring worksheet right here. And would you guys open it up? I think it's a Schoology quiz, and I just want to know how it starts. So just open up the Schoology quiz. I want to be able to swing by and look at somebody's so I can like show people how to get started on it. Minus what? 14. Okay. So this is apparently the first question. Does it say to do anything or just say factor?
Put the following quadratic equation in factor.
Okay. That's a fancy way of saying factor. All right, so let's factor this thing. And I'm nervous about this one because I'm like, how the heck are we going to make a 5 out of a 14? So we just one step at a time. 3-step process. Ian, there's only one Ian here today. So how do I start? 3 steps.
You put the X's.
Yes, that's step 1. What's step 2?
You want me to do all 3?
Just do step 2.
Add a plus.
A plus
And a minus.
and a minus. Yes, because this came out negative, you need 1 positive and 1 negative. Perfect. Grace. Finish it off. How do you make a 14? We got to fail fast here. Just try something and 7 and 2. Now we'll try it and see if it worked. Outside, negative 2x. Inside, 7x. Did we get lucky? Yep, got lucky. Because I didn't know I was putting them in the right spots. If I had them in the wrong spots, it would have come out to maybe the opposite of that. And it wouldn't have come out to 5x, it might have come out to negative 5x. This one came out to 5x, so I did it right. So what do you type in? Exactly this. This is the answer. X plus 7 parentheses, parentheses, x minus 2. All right. There's your factoring in a nutshell. So let's have you finish that thing off. How many questions are on the Schoology quiz? I think that's doable. We have a bunch of time, and this is so important. Strongly recommend, if you need help on this, come in the morning. Get help on this. Like, this is critical, not just to this unit, but to the rest of your math career. Okay, that's all I got for you for today.